Hi guys, this is AS Chemistry, Organic Chemistry, and we are doing Introduction to Organic Chemistry. Question 13. The structure of a compound S is given. The acid S shows stereoisomerism. Draw structures to show this isomerism and label each structure. So we have presence of two carboxylic groups on two carbon atoms on which two hydrogen atoms are present between a double bond. So this is a symmetrical alkene. So it has two CH groups present on the carbon atoms between which a double bond is present. So this is capable of showing cis-trans isomerism. So we are supposed to draw the structures of the two isomers which are cis and trans isomers. So we have a C double bond C with hydrogen on one side of the double bond and C double bond O single bond OH on the other side. So this is the cis isomer of this compound. And as for the trans isomer, we will switch the positions of the hydrogen and the carboxyl group on any one of the carbon atoms. Let's switch them on the carbon atom on the right. So C double bond O, single bond OH goes up and hydrogen comes down on the carbon atom on the right. And hydrogen stays up and C double bond O, single bond OH stays at the bottom of the carbon atom on the left, giving rise to the trans isomer of acid S. Question 14. Compound Q is a viscous liquid which is very soluble in water. The MR of Q is 90. Three possible structures for Q are shown. These are structures R, S, and T. What type of isomers do R, S, and T show? So R contains a carboxyl group and CH2OH, so an alcohol group. S shows an alcohol group and an ester group, and T shows an alcohol group and an ester group. So basically, R contains the carboxylic group, S and T contains the ester group. So carboxylic acids and esters are functional isomers. So whatever isomer do R, S, and T show? Functional isomerism. Functional isomerism is a part of structural isomerism. What oxygen containing functional group are present in R, S, and T? Give their full names. So in R, we've got a carboxyl group and a CH2OH, so carboxylic acid, and a primary alcohol. In S, we have got a primary alcohol and an ester group. And in T, we've got an ester group and a primary alcohol. So these are the two functional groups present in the three isomers given. Which functional group in rather in A2 will react with sodium carbonate? So that would be the carboxylic acid group. And which functional group in A2 will react with sodium metal? So sodium metal reacts with the carboxylic acid group and with the alcohol groups, whether they are primary, secondary, or tertiary. However, all three of them contain a primary alcohol. Question 15. A hydrocarbon P with the formula C6H12 readily decolorizes bromine. So that means it is an alkene. There are several structural isomers of P that also decolorize bromine, but only four of these structural isomers exhibit geometrical or cis-trans isomerism. Give the structures of any three structural isomers of P that exhibit geometric or cis trans isomerism. So we need to have two groups of the same type or the same group on two carbon atoms. So let's start with C double bond C, each having a hydrogen atom on it. So we have six carbon atoms in total. So we can have a CH2 and a CH3 group on the left and a CH2 and a CH3 group on the right. So this is one of the isomers that can show cis trans isomerism. Another isomer that can show cis trans isomerism would be two carbon atoms, one having a CH3 group and another one having a CH3 group. The first one having a hydrogen atom and the second one. So in total, there are four hydrogen, four carbon atoms being used up. So we are left with two. So CH2 and CH3. This is the second isomer that can show cis trans isomerism. A third one would be a carbon atom double bonded to another carbon atom, both having hydrogen on it. One of these would have a CH3 group attached to it, and the other one would have a CH2, CH2, and a CH3 group attached to it as well. And since they said that there are four isomers that can show cis trans isomerism and they asked for only three, three of them have been shown. Let's work out the fourth one as well. So it is very much similar to the third one, with two carbon atoms having a double bond between them, having one hydrogen atom each, the one on the left having a CH3 group, but the one on the right, now instead of having a CH2 CH2 CH3, it has a CH group which is bonded to two CH3 groups. So this is another isomer of the same molecular formula which can show cis trans isomerism. So these are the four structures that are capable of showing geometric isomerism that have the molecular formula C6H12. And all of them have been drawn in their cis isomeric form. Question 16. Ethanol reacts with hydrogen cyanide in the presence of a small amount of NaCN as shown. The product of this reaction shows stereoisomerism as it contains a chiral center. This reaction produces an equimolar mixture of two optical isomers. Explain the meanings of the term stereoisomerism and chiral center. So stereoisomerism means compound or isomers having the same molecular formula but different spatial arrangement of atoms. Spatial arrangement means arrangement in empty space. So they have the same structure as well, but different spatial arrangement of atoms. And the meaning of a chiral center is a carbon atom forming four single bonds with four different atoms or groups of atoms. So this is the definition of a chiral center. Suggest why the two optical isomers are produced in equal amounts by this reaction. So we have a molecule of CH3CHO. So CH3CHO is a planar molecule which can be attacked by a nucleophile from either side, resulting in the formation of both optical isomers. Question 17. Heptane C7H16 is an undesirable component of petrol as it burns explosively, causing knocking in an engine. There are 9 structural isomers with the formula C7H16, only 2 of which contain chiral centers. Explain the meaning of the terms structural isomers and chiral. So, structural isomers are isomers having the same molecular formula but different structural arrangements. And chiral refers to a carbon atom forming 4 single bonds with 4 different atoms or groups of atoms. Give the structures and names of 2 structural isomers of C7H16 which contain a chiral center. So the simplest one would be a carbon atom with hydrogen attached on one side, CH3 attached on another side, uh, CH2 and a CH3 attached on the third side, and we'll have a 3 carbon atoms, so CH2, CH2, and CH3 attached on the fourth side. So this compound will be called 1, 2, 3, 4, 5, 6. So this is hexane, and we've got the methyl group on the third carbon atom, so 3 methyl hexane. And we need to have another structure which has a chiral center present. So this structure would be a carbon with a hydrogen on one side, a CH3 on the other side, CH2, CH3 on the third side, and instead of a straight chain 3 carbon compound on the right, we can have CH, CH3, and CH3. So branching has been introduced in the group on the right. So the name of this compound would be 1, 2, 3, 4, and 5. So this will be a pentane, and there are methyl groups on 2 carbon atoms. So the name would be 2, 3 dimethyl pentane. And the carbon atom with the asterisk marked on it is the one that is the chiral carbon atom. Question 18. This question is about molecules with molecular formula C4H8. Give the structures of a pair of positional isomers with the formula C4H8. So positional isomers means the position of the functional group is different. C4H8 is the molecular formula of an alkene, so a double bond is present. So we can have the double bond present between the first and the second carbon atom. So that would be CH2 double bonded to CH, single bonded to CH2, single bonded to CH3, and its positional isomer, which would be CH3 single bonded to CH, double bonded to CH, single bonded to CH3. So both of these are positional isomers of one another having the molecular formula C4H8. Give the structures of a pair of chain isomers with the formula C4H8 that do not show stereoisomerism. So one of these would be an alkene with a straight chain carbon and the double bond on the first carbon atom so that it does not form any stereoisomer. So CH2, CH, CH2, CH3 is one of the two positional isomers, chain isomers, chain. So we are supposed to introduce branching, not positional chain. So if we are supposed to introduce branching, then this becomes easy. So we can have a double bond on a carbon atom with two CH3 groups on the same carbon atom so that it does not show cis trans isomerism. And we are left with one carbon atom with two hydrogen atoms attached to it. So this compound will not show uh, cis trans isomerism as well, but is a chain isomer of the compound on the left. Give the structure and full names of a pair of stereoisomers with the formula C4H8. So we need to form cis and trans form of the compound. So C double bond C, C double bond C in the cis isomer. The CH3 groups will be on the same side and the hydrogen atoms would be on the same side. This is the cis but 2-ene molecule. And if we have the CH3 on opposite side of the double bond and the hydrogen atoms on opposite side of the double bond, it still stays butene, but it is called trans butene. So cis butene and trans butene. These are the two pairs of stereoisomers having the formula C4H8. The structure of a molecule A of formula C4H8 is shown. Draw a functional group isomer of molecule A in box B. Explain how molecules A and B could be distinguished by a chemical test. So we can draw any alkene with the formula C4H8. So CH2 double bonded to CH, single bonded to CH2, single bonded to CH3. So these two are functional isomers of each other. And how can we distinguish them using a chemical test? Add aqueous bromine. The brown color would be discharged with compound B. Two atoms of bromine will add onto both the carbon atoms with a double bond between them. This is known as electrophilic addition, but this is the detail that is not required. The detail that is required is the chemical test and the observation. The chemical test is addition of aqueous bromine, and the observation is decolorization of bromine water. So the red brown color or the orange color or the brown color, whichever color is stated for bromine, is the color that disappears when it is added to compound B, which is the alkene. And nothing would happen when it is added to the cyclobutane molecule, that is compound A. Question 19. This question is about molecules with the molecular formula C4H8O2. Give the structural formula of the pair of chain isomers with the formula C4H8O2 that are carboxylic acid. So one of these could be a straight chain carboxylic acid having four carbon atoms, which would be COOH, CH2, CH2, and CH3, which is butanoic acid. And a chain isomer is basically introduction of branching. So we have a carbon atom chain of three carbon atoms, and one of the carbon atoms is a substituted group on the second carbon atom, and this carboxylic acid is 2-methyl propanoic acid. Give the structural formula of a pair of positional isomers with the formula C4H8O2 that are esters. So we have in total four carbon atoms. One of them will be the part of the ester group. So we are left with three carbon atoms. So on one molecule, we can have an alcohol with one carbon atom and the carboxylic acid having three. And on another molecule, we can have the alcohol having two carbon atoms and the carboxylic carboxylic acid having two carbon atoms as well. So the names of these esters, the one on the left would be methyl propanoate and the one on the right would be ethyl ethanoate. Give the reagents and condition needed to produce one of your esters in one B1. So the conditions needed for the reaction is we need let's make the one on the left. We need methanol, we need propanoic acid, we need H2SO4 aqueous as a catalyst, and we need to heat them under reflux in order to form the ester methyl propanoate. Question 20. In each section of this question, an organic compound is shown. For each compound, give its name and answer the question about it. So the organic compound shown here is an alkene with a branch present, and they want the name. So the double bond is closer from the right, so the numbering will start from the right. So 1, 2, 3, 4, 5, and 6. So this is hexene, and the fourth carbon atom has a methyl group on it. So the name of this alkene would be 4 methyl hex, and the double bond is present on the second carbon atom. So hex 2 ene. This compound shows stereoisomerism. Define stereoisomerism. They are isomers having the same molecular formula but different spatial arrangements of atoms. State and explain how many stereoisomers of this structure are there. So this structure is CH3, CH2, CH with a CH3 bonded to it, a CH double bonded to a CH and single bonded to a CH3. So in this structure, the double bond marked with the blue circle is capable of showing geometric isomerism, and the carbon atom marked with the red asterisk is capable of showing optical isomerism. So in total, we have two cis trans isomers present and two optical isomers present. So a total of four stereoisomers. So four stereoisomers are possible. Now, how is this? Now, first we begin with the blue circle. The double bond present is capable of showing cis trans isomerism with both hydrogen atoms on the same side forming the cis isomer and on opposite sides forming the trans isomer. The chiral carbon atom marked with an asterisk is capable of forming two optical isomers which are non superimposable mirror images of each other. So in this way, two optical isomers, a cis isomer and a trans isomer, results in the formation of four stereoisomers for the given compound. Question 21. In each section of this question, the structural formula of an organic compound is shown. For each compound, answer the question about it. So we've got CH3, CH2, CHBr, and CH3. So this is bromobutane, or rather 2-bromobutane. And since it does not have any double bond present, so the carbon atom to which the bromine atom attached is a chiral carbon. So this is capable of showing cis trans. This is not capable of showing cis trans isomerism. This is capable of showing optical isomerism because a chiral center is present. So name this compound. The name of this compound is 2-bromobutane. This compound shows stereoisomerism. Draw the two stereoisomers in the conventional way. So 2-bromobutane will have a central carbon atom to which we would have a hydrogen and a bromine atom bonded on opposite sides. And on the remaining two positions, we would have a CH3 group on one side and a CH2 and a CH3 group on the other sides, which would result in the formation of two optical isomers. So a hydrogen at the top, a bromine at the bottom. If we place a CH3 on the right of the isomer on the left, so the CH3 would be on the left of the isomer on the right. And in the remaining position, we include the CH2 CH3 group to complete the structure of the two optical isomers of 2-bromobutane. Give the structure of three other structural isomers of C4H9Br. So we can have a straight chain compound CH3, CH2, CH2, CH2Br, which is 1-bromobutane. We can have a tertiary halogen alkane. The carbon atom to which Br is bonded to by three CH3 groups. This is a tertiary halogen alkane, and the name of this compound would be 2-methyl, or rather 2-bromo, 2-methyl propane. And we can have another primary halogen alkane, but with a substitution in the chain. So this is the halogen alkane with substitution of an alkyl group. So this would be called 1-bromo 2-methyl propane. So these are the three structural isomers having the molecular formula C4H9Br of the given compound 2-bromo butane.